Live? All right. Good afternoon, everybody. Can you hear me at the back? Give me a wave if you can hear me at the back. Lots of waves, perfect. Thank you. So good afternoon, my name is Matt Woods. I'm the General Manager for Artificial Intelligence at Amazon. That means I get to get involved in pretty much everything that we do related to artificial intelligence, everything from Alexa through to the work we're doing with AWS. And I thought it would be great to spend some time with smart people such as yourselves today to run through some of the things that we're doing on the AWS side for AI and some of the services and capabilities that are available to you today, and then tell some stories about how some other customers are using AI on AWS. Let's see. This one. All right, so I read somewhere that all good talks start with a definition, and this is mine. At Amazon, we define artificial intelligence as a system or service that can perform tasks that usually require human intelligence. So this is any system which can see, that can hear, that can understand, that can reason, that can perceive, and we want to help customers build as many of these intelligent systems as possible. All right, my clicker is not working. I'm going to do it like this. All right. So as I mentioned in the keynote this morning, and I'll go into a bit more depth now. If you didn't see it, you'll get a recap and a bit more depth now. One of the challenges of artificial intelligence has always been one around scale. So a lot of the ideas related to artificial intelligence, concepts around neural networks and statistical machine learning, linear models, nonlinear models, convolutional networks, those sorts of things, a lot of them are actually really, really old. I did my PhD in neural networks 15 years ago, and a lot of the ideas haven't really changed. What has changed is the availability of removing a lot of the constraints related to achieving this scale. So in terms of data, neural network models and deep learning models require huge amounts of data. The more data you have available, usually the better model you can go ahead and train. I've seen models trained on exabytes of data, but typically gigabytes or petabytes of data will get you up and running, particularly with deep learning models. In terms of training, these models are incredibly computationally intensive. So a deep learning model can take days or weeks to go train on a large cluster of GPUs, and so you need a lot of computational firepower. And as I mentioned this morning, the dirty secret of machine learning is that once you've gone to the trouble of training these models, inferring predictions against them at scale with low latency is incredibly challenging. Typically, neural network models scale very, very poorly when you start to put more data through them for inference, particularly when you're using things like k-nearest neighbors. So there's a lot of work that goes into scaling for prediction, particularly when you're operating at the sort of scale that we operate at Amazon. So traditionally, all of these areas have been constrained in some way. Traditionally, in old-fashioned data centers, literally the data center walls couldn't move. And so you were restricted to the amount of compute and the amount of data that you could store and the ways that you could do prediction. Today, in the cloud, we've been helping customers overcome challenges of scale for over a decade. So we have customers today that have exabytes of data on the platform. You'd be surprised how many startups have exabytes of data available to them today. And most new data, either from IoT platforms, from web apps, mobile apps, or pretty much anywhere else, is being generated fresh and lives up on AWS. And pretty much everything else is being migrated as aggressively as possible. And we have services to help with both database migration and also data migration, including physical devices, such as Snowball. You should never underestimate the bandwidth of a truck full of hard disks speeding down the highway. And even our very own truck, which we call Snowmobile, which will provide exabyte level data transfer from your existing data center up onto AWS. We'll bring the truck, which has a container full of drives. We'll ship it to you. You get 24/7 security. We'll load it there into your loading dock, connect it up over fiber to your data center, load the data in. It takes a couple of weeks to load. We'll drive it to the AWS data center and unload it at the other end. It's by far the fastest way of moving exabytes of data. In terms of training, we have tons of GPUs available. Currently we have Kepler, NVIDIA Kepler GPUs up on AWS, but we're going to be a launch partner for the latest NVIDIA platform, which they're calling Volta. NVIDIA are great at naming things. And Volta is a machine learning and deep learning beast. It has hundreds of thousands of CUDA cores available for deep learning, and it means that your training will fly through it. And it also has optimization for inference as well. So you can use the same chip for training as you do for inference. And this is important because in some cases, the world of training and the world of inference are starting to merge together. So we're seeing adversarial networks which can train each other as they go through the training process. And we're seeing things like reinforcement learning, where as the model is being run, it's actually training itself. So chips that you can run inference and training on at the same time are becoming more and more important. And we'll have those up on the cloud as soon as they become available from NVIDIA later this year. They're available with elastic capacity, and we have pre-built images of pretty much all of the deep learning frameworks to get you up and running very, very quickly. So from the AWS Marketplace, you can make a few clicks. You can launch an EC2 instance, which is pre-configured with all the latest deep learning libraries. And as a result of overcoming all of these challenges, I've skipped forward again. I don't want to miss prediction. It's the most important part. So about 99% of the work in terms of driving these models is in making the predictions work right. So prediction, we provide the same elastic capacity for GPUs and the same elastic capacity for CPUs, which in some cases can be more cost-effective at driving inference. But we also see customers using serverless environments such as Lambda to run deep learning models. And this is beneficial because you don't have to worry about the scale and provisioning all the servers under the hood. You can just throw the inference workloads at Lambda, and it will automatically scale on your behalf. So as a result of overcoming these constraints on behalf of customers, AWS has really become the center of gravity for artificial intelligence, both at Amazon and with our customers. And the promise for artificial intelligence is really to be able to add new features for existing products using data that you already have. You can define entirely new categories of products and new product experiences using intelligent systems. And you can really advance material breakthroughs. And I kind of compare it to what it was like to build a web server 20 years ago. So 20 years ago, setting up a website was an incredibly technical challenge. It required a very rarefied set of skills, setting up databases and servers and Apache servers and all these sorts of things that only a small number of people could do really, really well. But companies that figured out how to do it well went on to become incredibly successful, companies like Amazon and Google and Facebook and so on. But today, any developer worth his salt, largely in part because of AWS, any developer worth his salt can go ahead and spin up a website very, very quickly. So today, whilst deep learning is a very rarefied set of skills, it's a very technical domain, we believe that in the fullness of time, it could be 2 years, it could be 20 years, but in the fullness of time, it will just be a common vanilla workload that almost everybody can run. And because it's so computationally demanding, at Amazon, we believe it's going to be the preeminent workload on the whole of our compute platform. So over 50% of the workload running on EC2 eventually will be made up of deep learning, either training or inference. There's a lot of work to do in bringing that future state closer to today, and that's what I'm passionate about, is making this stuff as easy and available and accessible to as many developers as possible, and that's what we're driving with AWS. So I mentioned some of these this morning in the keynote, but I'll run through them. I have some extra ones as well. This is an interesting use case for deep learning. This is work that Stanford did in the early detection of diabetic complications, specifically diabetic retinopathy. So diabetic retinopathy is extraordinarily common. It is the leading cause of blindness for men here in the US, and it is treatable in almost all cases if you can catch it early enough. The trouble is that catching it early enough is extraordinarily difficult. You have to look at images like this. This is a fundoscope. It's a picture of the back of the eye. And today, manually, physicians and radiographers have to look into the back of the eye, and what you're trying to detect are very, very small microvasculature changes at the back of the eye. So not those big ones on the retina, bottom right-hand corner, but the little tiny ones that are very, very difficult to see. And if you can detect it early enough, it's preventable in 90% of cases. So with Stanford, we took some healthy pictures, some healthy fundoscopes, and we trained a deep learning model against some unhealthy fundoscopes. And we're able to achieve physician level or better at predicting whether a patient would go on to suffer from diabetic retinopathy. We also have skin cancer detection, same general idea, taking little video cameras, pointing them at lesions on the skin, and being able to detect whether that, predict whether that lesion will go on to become cancerous, and we can do that at physician levels or better. And we do a lot of work with medical imaging. This is a sagittal section through the middle of the lung, and what we can do here is we're going to try and identify where the cancer is in this image. So certainly not to me, maybe there's some smarter people in the audience, but I can't see here where the tumor is. And this is the sort of raw images that physicians are having to work with. But we can start training some deep learning models, and we can start to add some additional information and give that back to the physician or the radiographers. Here we're not trying to replace diagnosis or automate it. We're trying to provide diagnostic support. It's just another data set. It's another data point available to physicians and radiographers. So the first thing we can do is we can start to build up dense matter like bone. This is relatively easy. It's radiopaque. You can see it on an MRI. But we can start to overlay that with soft tissues. So here you can see we're starting to add the lungs. And beyond that, we can start to identify the vasculature of the area. So this is very, very difficult to identify on an MRI. But using a deep learning system, we can start to tease it apart to identify it. And then when we start to overlay all of this information along with patient information, we can start to get a much more vivid picture of where the tumor might be. So this is the same image with a deep learning overlay, which shows the hotspot in the top right-hand corner of an area which is likely to be a tumor based on the vasculature and the soft tissue around it. We also run FDA-approved medical imaging. This is medical imaging which has been trained on patient information, in this case to be able to identify congenital heart defects on ultrasounds. And we have customers that are doing computer vision, a lot of computer vision. Deep learning today is excellent at computer vision. Being able to take sports images such as this and to be able to apply additional information over the top of it. So this is a startup company called Huddle. And what Huddle do is they take images from sports teams, both professional and amateur, and then they start to analyze it in weird and wonderful ways. So here on the right-hand side, you can see, just using this computer vision system, they've been able to overlay on that video, just raw video, the location of all the different players and the areas in which the players frequent most often as they're playing through the game. And you can start to identify which way they're facing, how they're passing, and how they're doing their various different plays. So here you can see a more advanced model, which is not just looking at the hotspots of where they are, but actually identifying the specific players inside the video and watching how they pass and how they interact and their movement and things like that. And this is very important as teams start to deconstruct how they're playing and start to work through more of their different plays. It's fun stuff. So here we have the world's best performing autonomous driving system in video. So on the left-hand side, you can see during the day, go back a slide, sorry about that. Get these playing. Nope. Let's try this. Okay. There we go. Okay. So on the left-hand side, you can see object detection. So this is a computer vision system which has been trained to identify people, other cars, road signs, things like that. And you can see that this system, which was trained and operates up on AWS, is able to operate during the day, where there's tons of information. You can see the car there stopping. This is normal traffic for Beijing, if you've ever driven in Beijing. And on the right-hand side, you can see exactly the same system running at night. It's a much harder problem to solve because you have much less information. You have black and white, much less contrast. You can see there they're doing a car detection on the right-hand side and object detection at night as well, actually running down there on the car. We talked a bit about this in the keynote as well, but here is real-time per pixel object segmentation. So here the deep learning system is trying to identify per pixel what is road and what is not road. And this is really important for autonomous driving systems because it allows you to start to read the different roads and the markings on the road, but also recognize where the cars are within that road. And if you start to pull all of this together, you can build out wonderful systems like this, which they rather unfortunately call SLAM, which provides centimeter accurate positioning. So here they're using just computer vision systems, object segmentation, and object identification to create a heat map of the depth of objects away from the car just using a computer vision system. So there's no sensors involved here. So it's obviously very important because you want to be able to position the car as accurately as possible as you're navigating a city environment. So if you can believe it, there are leaderboards for autonomous driving simulations. And this one from a company called Too Simple, a startup based in Beijing and San Francisco, routinely performs 2 out of the top 3 positions. So this is where the cutting edge is. We also have computational knowledge engines. So this is Wolfram Alpha up and running on AWS. And we have a lot of work being done with our friends at Pinterest who do visual search. So here with Pinterest, they have a deep learning model where you can draw a little bounding box against items inside the pins, and you can start to identify the specific items inside that. So if you see a lamp that you like in this example, you can draw a box around it, and you can find other pins that have a similar lamp. And this is another revenue stream for Pinterest because they also show where you can buy that lamp from and show ads against it. In terms of real-time usage, they actually take the same model, a simplified version of the same model, and drop it onto the mobile device inside their app. And they're able to do real-time object identification. So here, if you see some friends who have some shoes that you like, you can just point your mobile phone camera at it, and it'll start to pull out all the labels from the shoes and start to throw up pins which relate to those shoes. So this is all available on the mobile app today. Netflix do a ton of work on deep learning and artificial intelligence, machine learning in general. They do a ton of work around personalization, ranking, page generation, asset selection, search similarity, ratings, all those sorts of things. But what's most interesting is they were able to keep up with the growth of the business using these deep learning models, which are very sophisticated. So they're able to retrain their language models very, very quickly to be able to support the global launch for Netflix. So Netflix went from 39 different countries into 140 new countries simultaneously, and they're able to retrain all of their models. And here you can see Netflix running in Farsi with all the similar personalization and ranking that you would expect. This is a fun one. This is called neural style transfer. Some of you may be familiar with it. Here you can train a deep learning system on a visual style. So you could train a deep learning system on the Japanese woodcut style there in the middle. And then you can take that style and transfer it onto other images. So for example, you could take the deep learning network trained on woodcuts and apply it to the San Francisco Golden Gate Bridge there. And you get weird and wonderful effects that look like this. And you might wonder, well, what the hell is the point of that? But it's actually used quite frequently in media. So this is a paper which is in arXiv. You can read it online today, called Bringing Expressionism to Life with Neural Style Transfer in Come Swim. Come Swim was a big motion picture, and they used this approach to generate their title sequence. So they were able to train an impressionist deep learning model. They went out and just shot vanilla footage, and then they applied the neural style transfer to generate the title sequence for the movie. Now, this is interesting for two reasons. One, it's a super cool method. And number two, one of the co-authors was Kristen Stewart, who some of you may know as Bella from Twilight. So when I talk about artificial intelligence being for everybody, I really do mean everybody. So we have tons of customers that are running AI in production today. Zillow use machine learning to try and predict the price of a house. Stanford we talked about. We see natural language processing at Slack. Tons of work being done on IoT systems and health systems. And we have thousands of engineers focused on AI at Amazon. So we use AI dramatically across the organization. One area is in using computer vision systems to drive better throughput through our fulfillment centers. So we have very, very large fulfillment centers, and part of it is having the inventory in stock, and part of it is getting new inventory on board as quickly as possible, because during peak periods, things are going out all the time. And so we were able to use a computer vision system which basically maps incoming objects, make sure we got the right things in the right place, and that reduced onboarding time from hours down to less than 30 minutes. We also use it for robotic systems. I think I have a little video if we have this queued up. Let's see if this works. Let me skip here. So if you haven't seen inside an Amazon fulfillment center, this is what it looks like. So here are our Amazon robots. These are completely autonomous, operated up on AWS. And these little robots, they pick up and move inventory around for us. This means that we can dramatically increase the concentration of inventory that we store inside the fulfillment centers, because we don't need to have gaps between the different objects. It's not like a supermarket where you walk up and down. There's a waffle maker going to a lucky customer. Where you walk up and down the aisles and select things out. We use robots to move the inventory around because it's much more efficient, and they move the inventory to the humans rather than the humans going to pick up the inventory, which is a much more sophisticated model and a much more efficient way of fulfilling orders. So if you've ever bought anything on Amazon.com, there's a good chance it's been fulfilled and carried around on one of our robots. We use it extensively in search and discovery. Customers who bought this also bought. We do a lot of work in summarization and search, discovery, and personalization. We also use it to improve existing products. So popular one is X-Ray, which lives inside Kindles. Here we use natural language processing to dive inside the text. And here we can see one of the Game of Thrones books, pulling out all the different characters that exist and how they interact through the period of the book. We're able to do this not just in English, but in multiple different languages. So here's the same thing in Japanese. And we do this exact same approach with vision systems running on Amazon Instant Video. So here we're looking at episode 5, and even without being able to identify the faces, you can see the X-ray is looking inside the image and has correctly identified the different actors which are inside this scene, and helpfully the music which is playing, and a little helpful link so you can go buy the soundtrack on Amazon.com. We also use this to define entirely new categories of products, such as Echo. So Echo is a speaker which has Alexa, the personal digital assistant, living inside it. Alexa is a complex deep learning system that runs up on top of AWS. Most of the capabilities which we have abstracted out are made available to developers. And we also have new versions of Echo which have vision systems in as well. So this is Echo Look. And Echo Look is designed basically for style selfies. So you can ask Alexa to take a photo of you in the morning to assess what you're wearing. You can keep a diary of everything that you've worn, and it'll also make automated and semi-automated recommendations of new clothes for you to go wear. We do a lot of work with vision and IoT sensor fusion systems with Amazon Go. Amazon Go is our no lines, no checkout convenience store, which is currently in beta in Seattle. And with this system, you basically walk in, you blip a little device as you walk in, you walk around the store, you pick up whatever you want, pick it up, put it down. We have every manner of nefarious beta tester inside Amazon testing to try and trick the system. It does a pretty good job. But you can pick up whatever you want, sandwiches, cupcakes, put it in your bag, and then just walk out. And then we identify which ones you've picked up, and then we'll just bill your Amazon account a couple minutes later. And it's amazing how infuriating queues become after you've experienced a system like this. And so if all this sounds a bit futuristic, here's one of my favorite quotes from William Gibson that says, "The future is here, it's just not evenly distributed yet." And with the original business plan for AWS, the goal was to take technology which was traditionally only within reach of a very, very small number of well-funded organizations and make it as evenly distributed as possible. And we've done that with compute, we've done it with storage, we've done it with databases and data warehousing, and so we're taking the exact same approach as we've done with all the other areas as we're doing with AI. And we think of this in a couple of different tiers. So on the top tier, we have a collection of services which are pre-trained and available at the end of an API. So these are really for developers that don't have access to large amounts of data or don't have the skills to go and build and train their own deep learning models. Here we're abstracting a lot of the work, training it on behalf of our customers, and then making it available at the end of an API. And so for chat, we have a service called Amazon Lex, and Lex is what's inside Alexa. That's the clever naming that we have for Lex. And it is a natural language understanding and automatic speech recognition service for building conversational interfaces. And the way that it works is it basically takes natural language and it maps that natural language request to an intent. So here we can say the incoming question from a customer is, I'd like to book a hotel. Now what Lex is doing in the background is it's processing that text, gathering that speech, turning it into text, processing that text, and trying to understand what the question is. What is the intent behind the user? So this is very different from having to navigate the bells and clicks and buttons and swipes of a mobile app. Here you have a zero interface voice command where you can just talk to the system instead of interacting with it on a screen. And so we take that natural language, we map it to an intent, and we say, okay, well, now I know you want to book a hotel. So there's certain information that I need to go fulfill that intent on your behalf. So we would say, sure, what city would you like to book it in? And now the customer would respond well with New York City. And now we know that we're booking a hotel, and we're booking that hotel in New York City. And so we go through this process, and the system automatically helps the user navigate to collect all the information that it needs to go ahead and fulfill the intent on behalf of that user. So the next question might be, when would you like to check in? And you would say next Friday. And you can see here that the service remembers the flow that it's in. So you can have a natural back and forward with the interface, and you can just say next Friday. So what we have under the hood here is a knowledge graph. This contains a lot of information about dates and places and airports and hotels and all the sort of knowledge and associations as part of that. And we allow customers to specify a custom grammar graph. And the grammar graph is all of the domain-specific knowledge and how those pieces of grammar coexist. So things like booking it with city, the hotel names, and all those sorts of things can be supplied by the developer. And you can get these things up and running really very, very quickly. And once you've built one of these bots, you can expose it across pretty much any interface. Lex doesn't care where it gets the input from. It's just an API, so it'll take voice or text input. So you can integrate it with pretty much any mobile app. And we actually have example code through Mobile Hub integration. You can just click a button, connect up your Lex chatbot, and then drop out a sample code for Android and iOS to start integrating with Lex. You can expose it on the web through voice and chat, text chat. You can expose it through connected devices, such as we do with Alexa. You can put it through Amazon Connect, which is our call center in a cloud. This allows you to create an entirely new call center and then have Lex sit inside the call flow. And that allows Lex to answer questions on behalf of the customer. For example, we use this at Amazon to ask incoming questions, of which we get a lot. The most common question, which is, where's my stuff? So if we have the phone number of the customer, we'll go look up the account, we'll look up if something has been ordered, and then we'll say to Lex, look, this is the most recent order. Ask the customer if this is what they're phoning about. And the Lex will ask the customer, are you calling about your recent order of a 42-inch plasma TV? And if the customer says yes, then it'll say, okay, well, it's been delivered. We expect it to be delivered next Friday, things like that. It can also collect additional information, disambiguate, and then route calls to the appropriate agent on the back end, all automatically. You can also integrate it with apps as well, like Facebook Messenger and Slack. And on the back end, it can tie into pretty much any data source. We have pre-configured connectors for things like Salesforce, Marketo, Microsoft Dynamics, QuickBooks, Zendesk. But you can tie into any back-end system or any back-end data that you have running on AWS through Lambda integration. We have a lot of customers, as you can see here. So Capital One allow you to interact with your bank account, ask what your remaining balance is and what your credit limits are and all those sorts of things. And we've done a lot of work with the American Heart Association. So now it is my absolute pleasure to welcome up Mark, who's going to talk a little bit more about what the work that we're doing at the, David, to talk about the work that we're doing at the American Heart Association. David, come on up.
Thanks, Matt.
Thanks.
Thank you.
Cheers.
We're working? Okay, thanks, y'all. Presented a little earlier today, so hopefully this won't be too redundant. I'll try to tie it more to the things that Matt was talking about, but still go over some of the same issues that we're working on. You know, for all the reasons that Matt just articulated, this is very important to us. You know, as a nonprofit, how many folks are with nonprofits? Quite a few, okay. So some of this will resonate, I'm sure, with what you're doing. It's very important in this time, being a nonprofit, who depend so heavily on the work you do being funded through donations to stay relevant. I won't use the M word. I spend a lot of time with marketers. I'm so sick of hearing about millennials and everything like that. It's all I've heard about for the last 2 months. So we'll just talk about them. But, you know, if you've been sitting in through some of those conversations with marketers and things like that, you're thinking, the big question, how do you stay relevant? How do you make your experience as a nonprofit, which is donation-based, relevant to a generation that values experience over stuff, as they say so often? So a lot of that goes into what we're saying here. It's just a little clicker thing. Let's see if I get this right. I'll just use this. Is that right? Okay, so our mission at the American Heart Association is simple: to build healthier lives free of cardiovascular diseases and stroke. That's it. Everything we do is built on that mission statement, and that, being as simple as it is, implies a lot of work has to be done, and there's a lot of areas under that. We have advocacy, we have research, all sorts of different lines of business that go into that. Our backbone of our organization is research. We've funded over $4 billion in cardiovascular research since our inception. Oops, how did that happen? So we've really boiled down our strategy relevant to the Lex and the Alexa platform and other components. I liked what you said about not being evenly distributed. You know, we're very focused on the user interface right now and trying to bring some of that to bear, but we really want to get into, and it's kind of logical in some of this, that deeper learning and applying that once we get some of this user interface and engagement pieces figured out. But really, those are our two strategies: ease of access to relevant AHA information. We're in large part an informational organization for the general public. We do all that research, and then we turn around and make it available. And a frictionless engagement with the organization. So we have a lot of services as well, and we want people to have that good experience and ease of use on what we do. So those are the two drivers around our work on these platforms. This is just really our vision. We want to bring it all together in a single user experience and not have folks have to go over a myriad of digital properties to engage with the organization. So we started, for us, back in December with Alexa, and we built out our skill and a very few intents here, but it's some of our core things. Learning about warning signs of a stroke, and then CPR, kind of out of the gate. I think this one plays a little bit here. Let's see.
Welcome to the American Heart Association. Heart disease and stroke are the leading causes of death in the world. To hear about life-saving advice from the experts at the American Heart Association, you can say, warning signs of a heart attack, warning signs of a stroke, or learn CPR. Now what can I help you with?
Learn CPR.
Here are instructions for doing CPR on teens or adults, according to the experts at the American Heart Association. If someone suddenly collapses and is not responsive and breathing normally, the first thing you should do is call 911. Next, push hard and fast in the center of the chest at the rate of 100 to 120 beats per minute. An easy way.
Oh, she was going to say easy to remember is push to the beat of the classic disco song Staying Alive, which is true. And then it goes in sort of metronome. But you see the concept there is, and let me see, I'll stop it from playing again, hopefully. And this is relevant across any sort of health-related industry. You know, for us, there's more than 350,000 out of hospital cardiac arrests every year, and 70% of those happen in the home. So what else is in the home? Alexa's in the home. So the vision there is, can Alexa actually serve the role of a CPR professional? Teach you how to do CPR, walk you through it in case of emergency. There's been a lot of talk about what if Alexa could call 911 and give coordinates, and we've had some conversations around that. I'm sure a lot of people in healthcare are interested around something like that, more complicated. But I've also learned, I didn't know this, that 50% of the 911 facilities in the United States will not give you CPR instruction on the phone if you call. The other 50% will. We trained them. But depending on where you are, 911 may just go, ambulance on the way, good luck. And the other 50% might actually talk you through the process of giving CPR. So we need to fix that, but we see this technology as a way to go right into the home and provide this service. This is really around our Lex strategy. We want to bring all those elements together. We've got 3 POCs going with AWS right now. One is around our NEC, which is our National Service Center, which is a logical place to start for bot and AI in terms of, lots of calls, 250,000 a year come into our call center, and they range, believe it or not, from I'm having trouble making my donation, I need information on X, Y, or Z, to it's literally happened, I'm having a heart attack, what should I do? And so our call center folks have to be ready for anything at any given moment because people call us instead of calling 911 sometimes. So thinking about what we could do there to offload a lot of the standard repetitive calls that a bot could do and then hand that over to a human being when it's appropriate and let the human beings focus on the more complicated work. So we're starting there. Heart.org is our flagship website. A lot of content under that, 7 major content areas. So how do we provide information better there? And then I asked about the nonprofit thing earlier because fundraising is super important if you work for a nonprofit. That's your lifeline. That's your revenue source by and large. So we're thinking about, in terms of that frictionless engagement, that's where some of this technology comes in around fundraising. How can we make that more engaging? How can we make it more relevant? We're an old organization, so we're in this transition from these are the fundraising techniques that have always worked for us, and now we've got to think, we want to stay ahead of that curve. How do we get into that space where we're more agile and more relevant? Our Heart Walks is one POC we did using the bot. We have 300 and something of those a year. They've funded about $1.6 billion in research since their inception, so very important to our mission. This is the architecture real quickly that we have in place. We've got Lex doing the work as the user interface. Lambda, as some of you know, from working on AWS, that's really where a lot of the magic can happen. You can write all sorts of code to do all sorts of things. Lex can just be that conduit to your end user, having the conversation through natural language, pass that into whatever Lambda functions you have. The AWS back into we use Blackbaud for fundraising, so back into our Blackbaud system to bring account information, any sort of contextual thing. And we just focus on having folks being registered. That's the gateway to everything. If they don't get registered, they're not going to participate in your event. So that's what we're focusing on right now. You know, one very interesting thing we talked about in the earlier conversation was, and I don't know how many folks were there, but the single most difficult thing we're having trouble with, so I'll just pass this on to y'all in case somebody can solve this problem, and we had some suggestions come up, is out of all the things we're doing with natural language, it works almost perfectly, as long as there's some context, but it's email address. Everything in front of the @ symbol, if you think about it for a second, there's no grammatical rules. There's no natural language rules applied there. There's no context for it to say, oh, you said this in your last conversation, so I'm ready to listen to this. It could be anything, and we've encouraged that. You know, everyone has. It's like your password has all sorts of capital letter and a number. Email address can be anything you want. You can spell anything any way you want. I used the example last time of, you know, zazzypants@gmail.com. You know, is that ZAZZIYPANT, ZPANT? And a natural language processor isn't necessarily going to know because there's no grammatical rules in play there. So until somebody solves that problem, we're having to think of workarounds, you know, saying in our bot, you may want to type this for better accuracy. But until you want to have a 100% natural language conversation around any sort of functional bot that's going to register you for something or do some work for you, somebody's going to need to figure out the email problem. Just putting that out there. So that's a bit of our bot for registration. You go to the walk, it pops up, you can have the conversation. The nice thing we've got going is at the end, it gives you a summary and gives you a chance to edit. And then there's some opt-in things that our legal department loves to have. So it's kind of nice because to opt in, when it asks you, do you agree to terms? And if you say no, it shuts down. If you say yes, it registers you. So there's no validation needed. It wouldn't have registered you if you hadn't said yes. So it makes it pretty nice for us. And then the end user gets an email back. Our second POC is around a program we have called Healthy for Good. This is a big effort new within the American Heart Association to promote general wellness. It's all about eating, recipes, adding color, moving more, exercise. It's just getting off the ground, and we really want to tie this into activity and tracking activity. That's for us. We create a lot of the guidelines that go into health-related activities that are used by third parties to measure against anyway. So we want people to track their progress against us. So the bots play into that. We're working on this tracking bot. I had a little movie earlier. I cut it out for time's sake. But in essence, the AWS guys have come up with this. And a really, really good blog went out on Friday. If you go out to AWS blog site, under AI, Bob Strahan, Oliver Atua, and Bob Potterville wrote an article that really outlines their work on this exact tracking bot. It's pretty cool. So the end user, goes in, sets their goals, whatever they may be. These are health-related goals here, and then just comes back on either a website, their mobile device, and talks to it. And in the little video, it just says, I ate 4 cups of apples today, and it tracks that, updates it, and boom, you're out. And then you can come back in and track it again. So you can extend that to mobile use, keep it on a website, and that's kind of goes back to our vision of the 360. There may be times when I want to interact with this function on a mobile device. There might be times when I want to use my laptop. So that's the nice thing about the bot technology. It makes it non-device specific, so you can free it up, as Matt had pointed out on an earlier slide. And our last POC is just your general FAQ type bot. That's where the Service Center comes in and heart.org. We really, really want to make it faster and more relevant when you're searching for our information. So all those kind of things we want to bring back, graphical elements, et cetera. And then, we're hoping we can add in some geolocation, and this is where there's a lot of room here for more learning. If you had, say, Sitecore profiles involved, And they already can help with bringing back relevant content, but can we add in that deeper learning and anticipate, do some predictive things, bring back more relevant content when folks are interacting? So the little thing here is this is our heart.org site, classic site. It's a good site. It's a good website. But if I go out there and I want to search for the warning signs of a heart attack, I might search under conditions. I might use the search functionality. Let's say I did, and it brings back a good list of things, and there's the warning signs for a heart attack. Now I drill down into that property, and however deep I have to go to get the relevant content I'm after. So wouldn't it be better just to have that conversation at the top level? I ask for some content around warning signs, and the bot brings back the relevant content and just the relevant content from however deep that information was. Now I can move on to the next thing. I might ask to register for a heart walk next or something like that. But you're having that single experience at the highest level of the digital property, and all I'm doing is talking to my device. But better yet, if you do get down to that level, there's a really cool graphic that someone in our graphic design department created. So why not just bring back the graphic using response card technology that's built into the Lex platform? So there's a lot you can do with this. You can have a much quicker, much deeper, faster, frictionless engagement with your user by just bringing back the relevant content and even bringing it back graphically, perhaps. So those are the things we're working on. Like I said, we're sort of focused on that top level of getting these sort of interfaces going. But you can see with the CPR example where more machine learning could come into play definitely around that. The healthy for good, maybe we can anticipate based on some data you gave us what some recommended. We can't make diagnosis, but we can make recommendations on sort of lifestyle changes, diets, things like that. For example, I set my goals and I come in and I'm like, I ate a cheeseburger for lunch, sorry. And it could say, okay, that's all right. Well, maybe you should eat this for dinner because you did that earlier in the day. So getting into that space is really the next phase, and we're pretty excited about it. A lot of thanks to AWS team for all the help they've done and all the great partnership they've had with us. And I don't know what that is. But thank you very much.
Appreciate it. Thank you. All righty. If we can go back to the slides real quick. Have a couple more things to run through. Thank you, David. That was awesome. I've read that blog post about the rings. It's fascinating stuff. So that's a quick overview of Lex. We also have a speech service called Amazon Polly, which does text-to-speech. And this is a speech service, so I thought we'd try taking a listen. You heard a little bit of Alexa speaking earlier. Polly is the same service that we use to generate the voice of Alexa. It has 40-plus different voices in 20-plus different languages, and they're designed to be as lifelike as possible.
Alice was beginning to get very tired of sitting by her sister on the bank, and of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversations?
So that's the first paragraph of Alice in Wonderland that I just cut and pasted and threw into the Polly console. And you can see just how lifelike it is. We're taking care of pronunciation and all the rest of it. We also try and do as much work on behalf of the developer to create lifelike voice automatically. So some of these examples, if you just read them out naively, like today in Seattle, WA, it's 11 degree F. It doesn't sound very lifelike at all, but what we do is we do text pre-processing and we expand out the statement so it sounds more natural.
Today in Seattle, Washington, it's 11 degrees Fahrenheit.
So we took WA and turned it into Washington, degrees F into degrees Fahrenheit. And we can also determine context and pronunciation based on the context. So we can differentiate between live and live.
We live for the music live from the Madison Square Garden.
So the pronunciation is correct based on the context as you would read it. We also try to make it intelligible and easy to understand, so you can do some fun tongue twisters.
How much wood would a woodchuck chuck if a woodchuck could chuck wood?
And we try to add as much semantic meaning to text. So in cases where we can't determine the right thing to do, we allow the developer to prompt what the right pronunciation is. So naively, we may pronounce a phone number, for example, incorrectly.
Richard's number is 2,122,341,237.
Not ideal, but if the developer tells us it's a telephone number, then we try and do the right thing.
Richard's number is 212 2, 3, 4, 1, 2, 3, 7.
So here we slow down, we put the pauses in the right place, because usually when you're being read out a phone number, then you want to write it in or type it into something as you're going through, so that's why we slow down. We also provide customized pronunciation. This is useful for video games and other character-based work.
My daughter's name is Kaja.
So you can differentiate that from,
My daughter's name is Kaya.
there we go. We also provide other more advanced features like whisper voices, which to me sound kind of creepy, but customers seem to like. So we have a lot of customers using this. I mentioned the Washington Post who are building this into their content management system to narrate all of the articles that they're running. Amazon Rapids recently swapped out their own voice system for something that we built with Polly. And Duolingo A/B tested, actually with their own customers, 6 different voice services. And as a result of that, made a data-driven decision that they got the best response from their 170 million plus customers who are learning languages to use Amazon Polly. So we think it's the best out there, and some of our customers are agreeing with us. The final service I want to talk about was Amazon Recognition. We talked a little bit about this. I announced this morning that Recognition is going to be available in GovCloud. And Recognition provides automated image analysis. So you can punch in any image, and Recognition will look inside the image to tell you more about the image. So here you can see we have an image which is relatively difficult to describe, even for a human. But Recognition does a pretty good job. It identifies that there's a skateboard, there's a person in it, there's parked cars, this is probably at an intersection, and the numbers you see there are a confidence score. So it'll tell you how confident it is that it's seeing what's inside these images. And you can make a cutoff and make a decision about where you use that. We recommend about 70%. We also do facial detection, so we'll identify bounding boxes of where faces exist, which is useful for creating thumbnails. And we'll also do some facial analysis, so we'll say whether people are happy, whether they're sad, whether they're wearing glasses, so on and so on. And we have some pretty advanced facial search features, so you can do facial similarity matching, which is useful for security, and also facial search. You can say, given this image, tell me which of these images out of these billions, potentially, this face appears in. And we see a lot of customers using this today. C-SPAN is a really nice example. C-SPAN take 1 frame every 6 out of their 8 broadcast channels, 2 broadcast and 6 on the web. And they send those into Recognition, and they have loaded in 99,000 different politicians into a private custom dictionary. And they're able to identify who is speaking about what up on C-SPAN. And they take all that information, they throw it in a database, and they're able to quickly query who's been on TV saying what using this internal index. They built this in just 3 weeks. As soon as Recognition was released. So it just shows how quickly you can start to add these pretty advanced capabilities at the sort of scale that C-SPAN needs. We also see a lot of work in the public safety area. So Motorola Solutions do a lot of work in identifying missing persons. So they have a private catalog of missing persons, and then they take streams from various different sources and try and identify who's being lost. And this is a task which humans are extraordinarily bad at because it requires continuous attention. You have to know a lot of the different faces, and you have to be continuously watching, potentially thousands of different streams to try and identify that missing person. But here, you can just have the machines do it. Have the machines do what they do well. The humans can do something which is more valuable. And the Washington County Sheriff Department use Recognition. They have a private database of 300,000 persons of interest. They loaded that into Recognition, and then they take images from different sources, send it through Recognition, trying to identify these persons of interest. And as I said in the keynote this morning, we had our first Recognition-based influenced arrest, when Recognition identified someone that was part of a cold case. They were able to go on and alert the Sheriff's Department to go pick them up and make the arrest. They were able to reduce the response time of their officers down from 3 days as they're processing all these different photos down to minutes. So a material increase in the responsiveness in terms of public safety. We also have platforms for building custom models, and we also have the engines that I talked about this morning for building out deep learning models. This is really the remit of researchers. It's a highly technical domain today, but we support all of the engines that you might expect, including MXNet, TensorFlow, Caffe, Theano, PyTorch, CNTK. We've run pretty much all of these in production at Amazon. We're happy to run all of them today on AWS. In fact, we have more TensorFlow workloads running on AWS than any other provider today. But the one that we like most is MXNet, and that's the one that we use pretty much across Amazon. And the reason we like it so much is because it has really incredible scaling capabilities. When you're training deep learning models, as I talked about earlier, you can get access to the compute resources, you can get access to the data, and MXNet provides the engine to actually train the data in a reasonable time frame. So you can see here that in terms of efficiency, 100% efficient is perfectly efficient. If you double the number of resources available for training, you get double the image training throughput. And here you can see MXNet scaling at 88% efficiency, scaling to hundreds of different GPUs. So if you're new to distributed systems, this is pretty remarkable. What a common system that we see, a common workflow that we see, is customers training models against very, very large data sets up in the cloud, running inference in the cloud, and then taking those models and running inference at the edge in embedded devices. So using computer vision systems, drones, et cetera, et cetera. And here MXNet excels because the models that it creates are extraordinarily efficient. They're about half the size in terms of memory utilization as other engines. And that means that you can take them and you can run them in more constrained environments. I talked a little bit about this. This is a good way to get started, just as we wrap up. We have a deep learning army, which with one click gives you an environment where you can access up to 40,000 CUDA cores, and we'll extend that to Volta at launch. You can access a pre-configured, pre-installed, optimized version of MXNet and TensorFlow. You can run Python 3. There's tons of notebooks and examples on there. And with a single click, you can scale that out to hundreds of GPUs when you want to go do your training. And a special offer just for you guys, we don't talk much about this, but we also have a research funding program. So this will provide cash and credits to fund faculty and students inside computer science departments. We provide a research symposium once or twice a year to gather together the researchers and have them talk about the work that they're doing inside deep learning. We make available our Amazon AI research team. We have an incredible team that helps build out all of these products inside Amazon, including Alex Smola, who's one of the fathers of deep learning. He has 75,000 citations related to deep learning and machine learning. And we'll also provide access to ad hoc credits for special projects. So if you find something that's coming up that you want to really scale out on, we'll provide credits to do that, along with teaching content so you can go teach students how to get all this stuff done. And if you're interested in that, you should drop me an email. I'm matthew@amazon.com. And with that, I'd like to thank you very much for your attention. Thank you. And I'll be down the front if anybody has any questions. Thanks.